Hey there. So you can see what I've created here with SceneKit. I got a nice basketball and it reacts to all sorts of physics. You can see it's spinning just a little bit just because it's kind of resting a little bit. SpriteKit is for 2D while SceneKit is for 3D. So here's this example I built. I had the gyroscope rolling the ball around when you tilted the iPad, but then Beta 3 came out and SceneKit doesn't seem to currently work on 32-bit devices. I have an iPad too. That's why it seems to work for this iPhone 5S. So if anyone wants to buy me a fancier iPad, please feel free. So this example I built, you can see that the basketball reacts to physics. SceneKit and 3D in general, it has a lot of terminology that's more than just X and Y coordinates. It's about normals and geometry and lights and camera and action. So in order to do SceneKit, you don't necessarily have to understand all of that 3D stuff because it can get very complex. SceneKit does provide sort of a nice, prettier layer on top, but it does help to understand a little bit. So I'm just going to explain a little bit of the 3D. When you're working with 3D artists, in this case, I didn't work with any 3D artists. I found stuff online and I used geometry that was available, but you can work with 3D artists who will build 3D objects for you, and that 3D art is going to be put into a DAE file. That's what you want to ask them to export. And that DAE file, most 3D editors can export that sort of DAE file. We won't be working with the DAE file today, but you should get familiar with them. When you use a DAE file, it can describe almost everything in your 3D scene that you need to know about, including the geometry of the objects, the animations, the lighting, the materials, the points of view, the skinning and morphing. But you'll load the DAE file through Interface Builder, but you can also load it with code. The default SceneKit comes with everything you need to just start programming. So you'll have your SCN view, just like you had your SK view for SpriteKit, which everything will sort of sit inside. You'll want to put some sort of 2D GUI on top of this, meaning like buttons to say play, or maybe you'll have a score or something like that. All that will be done in 2D. And to do that, you'll add on top of the SceneKit, you'll add a SpriteKit layer. If you haven't watched the SpriteKit tutorials yet, go watch them. It'll really help you with the SceneKit tutorial. You'll give the view a scene to work with. This is SCN view. You'll give it a scene that it's supposed to work with. And there's currently a couple of bugs in SceneKit that if you want to use the physics like we wanted to use the physics, then you'll need to create a bridge. Now, you probably won't need to do this once this comes out of beta. So if Xcode is out of beta, then go ahead and ignore what I'm about to say. Hopefully it works properly then. But there's this bug where if you want to use the physics, you kind of have to create a Objective-C bridge, and I'll show you how to do that. So we'll add some gesture recognizers to do stuff like when you click, it'll kind of zoom in and do this nice little effect. I don't know how high the frame rate is. And you'll get callbacks to say when that's done. We'll create the initial scene with lightings and camera, and there's different types of lightings available, and it's good to just know what the different ones are. There's ambient light, and ambient light illuminates in every direction equally. So an ambient light would be like in your room right now, probably it isn't completely dark. There's an ambient light that's providing light for your whole room. There's an omni light, which is from a single point. There's a directional, which goes in a single direction only. And there's a spotlight, just like how a spotlight works. What we have here is we have an ambient light and we have a spotlight. We're going to use ambient lights and spotlights together. And you can have different types of geometries also available to you. You'll have spheres and cubes and all sorts of other stuff. You saw the ball that we created, that was a sphere. And we're going to use the sphere for the basketball. And we'll use a bunch of planes, which is another type of geometry, to create this floor. And there's also walls on the side. So if you decide to create a bunch of basketballs, they'll hit those walls and they will bounce back. At the end of this, because I know nobody's staying in for this whole tutorial, you get to see what's on the other side of this. I took this tutorial straight from Apple's Worldwide Developer Conference and I modified it, but they had this really cool wallpaper here. So I grabbed that wallpaper and I added it on, and they had a really nice wood floor, so I grabbed that as well, but I thought it looked more like a basketball court, so I added a basketball. And you'll add the gyroscope so that you'll tilt it and the ball will roll around. You'll be able to do that as well. but I can't do that right now because currently it's not working for 32-bit systems. We have spheres and we have planes, and you have other really cool ones like toruses. Then you'll add textures. You can see the texture of the wooden floor and the texture of the wallpaper, and we add the texture of that basketball as well. The geometry is the shape itself. So your geometry is made up of a bunch of triangles, a bunch of polygons. That's how 3D works. And if you look at old school 3D, you can see those triangles individually. Those triangles are connected to vertices. Those vertices have what's called a normal. It just tells you what direction the surfaces are going. And that's why you have normal mapping. Like if we use normal mapping on that basketball, we could create the actual little lumps of the basketball that a basketball has and the little grooves. We could use normal mapping for that. So it's the direction of the surface, the individual surface. You may also have UV, which tells how an image should be mapped on the object. Like you saw that basketball had an image mapped on it. You may have materials that define how the texture will appear on the surface. And you'll also have cameras. You could have the camera that automatically follows the ball as it bounces. And the cameras can also be included in your artist's DAE files that the artist gives you. In our case, we'll create everything manually. We'll position everything, the cameras and all that stuff. Your materials can have different properties. So these are diffuse. This is the color of different things. You can create geometry that's black, and you'll use diffuse for the color of that. Ambient is the color that it emits when it's being reflected, because it doesn't just have to reflect exactly. It could emit a specific color. You have the shininess, which is the specular. The reflective, which is you can create an image that it will reflect. You've seen that famous picture of the guy holding the big glass ball, and you can see his picture reflected in that. You could create that by telling it what image you want to reflect. You have the transparency. You have the normal, which I talked about earlier, which is the direction of all the surfaces. The bump map, that they call it. You have multiply, which is the light maps or the shadow maps, which is visible even when it's not getting any light at all. So that's what emission is. So let's just create our project. I gotta stop talking. So what you'll do is you'll create a new project, and that'll be a game, and we'll just call this basketball. And make sure it's Swift, make sure it's SceneKit, make sure it's universal. And so now you have everything you need. It's going to be universal, portrait, landscape, all that stuff is good. It comes with something that you can run here, and if you run it, you'll see what it builds. It's a very simple 3D scene, and it shows the frames per second on the bottom, all that good stuff. We're going to delete all that stuff, so you'll go right into your game view controller. The main storyboard is set up already with our SCN view, which is very similar to the SpriteKit SK view. So if you haven't watched the SpriteKit tutorials yet, go watch them. So here's our SCN view, which everything will go into. And in our game view controller, we will delete everything in view did load. We'll delete everything in handle tap. In fact, we'll just delete handle tap. We'll leave auto, should rotate. We'll leave everything else. So in the typical fashion of your first SceneKit thing, we're going to create everything in one giant file. In our viewDidLoad, we're going to call super.viewDidLoad because we want to make sure you do that. The other thing we're going to just do is we're going to call a function called setup, which is not created yet. And we're going to do this by just creating a bunch of functions that do one thing, like setup scenes, setup this, whatever. This one's just going to be called setup. I took this from the Objective-C code and I turned it into Swift code. So you'll tell me if you see some stuff that should have been written in a different way. So we got to create a constant that will be our scene view. This is just going to be a shortcut to the self.view, but we'll just write view as SCN view. So now we have our view. We'll just call it scene view. We'll set the background color. We'll import SpriteKit because we'll want to put a 2D GUI on top. SpriteKit. And then with the background color, we can use our SpriteKit color dot black color. And then we'll call something called setup scene. And this will, as you can guess, set up our scene. We'll do setup scene. Before we do anything there, we'll just finish the rest of our initial setup. What we want to do is we want to give our scene view an actual scene. So we'll create a scene up here. This will be an SCN scene. So we'll create a var scene is going to be of type SCN scene. We'll put an exclamation on the end to say we don't need an initializer. We can promise you that we will provide an SCN scene for this scene. Otherwise, if we took that out, we'd have to create an init method. which is fine. Now we'll just provide our scene to our scene view, which is the actual view in the main storyboard. This is the scene itself. We're gonna give it an SCN scene with which to render all the 3D stuff on top of. So we'll say scene view.scene is equal to scene. Swift doesn't have public and private modifiers yet, so sometimes when you want to do stuff privately, you mark it with an underscore. So we'll do that for this tutorial. Take it or leave it, do whatever you want, doesn't matter. We're just going to say that this is kind of an internal scene. So that's what the underscore kind of says. It's like it's private. Nobody else should be modifying it, even though Swift is going to have those modifiers. It doesn't yet, so we'll kind of make our own. We need to create the physics world speed and stuff, but in order to do that, we need to create two bridge files, a header, an H and an M file for Objective-C, because this was not properly mapped yet. If you are currently using the non-beta version of this, you probably don't have to do this. So you can skip this part. So we'll call this physics world bridge.h. So this will be our header. We just need to import SceneKit, SceneKit.h. Interface. We'll call this the physics world bridge. Make this inherit from NS object. This is only because there's a current bug and we want this to work for us. If you still want to try it, you got to make things work, right? So physics world speed we want to be available, and that will be an SCN scene. Don't worry if you don't totally understand all of this. Sometimes you just got to make stuff work. And we need a scene with speed, which is a float and speed. We also want physics world speed, and we want physics gravity, SCN scene with gravity, and that's going to be, gravity is going to be an SCN vector 3, which just means it's a vector that takes three things. So it's going to be your X, Y, and Z coordinates, and that's going to be your gravity. Now we just need to create the M file, new file, M file. And we'll do physics world bridge.m. And it's going to ask us if we want to automatically create the bridge header, and you're going to say yes. So it's going to create another file for you that's going to automatically do everything to kind of bridge the gap between Objective-C and Swift. Just kind of pasted this in here, and I'll provide the source, but basically what we're saying is we're saying the scene physics world speed is equal to the speed, and the gravity is equal to the gravity. We're just kind of making these things available to Swift. If we look at the basketball bridging header that it created, we need to actually write some stuff in here to make stuff available to Swift. And all we have to do that is we just have to import the header so that it'll be available to Swift. We'll just say physics world bridge.h, and that's our header file. So now we're good to go. We can go back to our game view controller. All the confusing stuff is done with. Because we created that bridge file, what we can do is we can grab the bridge, which is that we can say physics world bridge, going to be a new one. We can say bridge dot physics world speed, and that's going to be the scene view dot scene. So it wants the scene that we want to do, and then the speed is we're going to use 2.0, and then we can say bridge dot physics gravity. There we go, and that's going to be the scene view dot scene is the scene that we're using. The gravity, we're going to create a new SCN vector 3. We'll use the make to create it. We'll use 0, -70, and 0. For the gravity, which means nothing on the X and Y, which means there's not going to be gravity pulling you left and right. It's not going to be gravity pulling you on the Z-axis forward and back. There's only going to be gravity pulling you up and down. Now, normally what you would do for that is you would say scene view. If this was working, you would say scene view dot physics world dot speed, and then you would say is equal to 2.0. But you can't do that because there's a bug. So then we just have to say who's going to be the delegate that's going to get all the function calls. It's going to be this. So we're going to say scene view dot delegate is equal to self, meaning this game view controller is going to receive all of the method callbacks. And in order to be a delegate for a scene view, we need to add a couple extra things up here that it implements. We need to say that it implements an SCN scene renderer delegate, and we say we also want to do SCN physics contact delegate. And this way it will respond to these callbacks, because we also want it to respond to physics stuff as well. We'll say scene view.jittering enabled. And if you look at what that does, Boolean value determines whether SceneKit applies jittering to reduce aliasing artifacts. I'm not completely sure what that does, so I just know that in the Objective-C code it was set to true. We'll set the initial point of view, so we'll say scene view.point of view, and this is where the scene is going to be rendered from, and we'll use a camera node that we didn't create yet. So let's create that camera node, because everything is an SCN node. The cameras, the lights, everything is going to be an SCN node, just like everything is an SK node. But even the cameras that you view things through is a node. So now we have a point of view because we have this camera. We didn't really set up much with it. If you wanted to create an overlay using the a SpriteKit overlay for 2D kind of gooey stuff, you could do that. You could say var overlay is equal to some sort of SpriteKit overlay scene that you created. That's just got to be a SpriteKit scene, an SK scene. And then what you would do to assign it is you'd say scene view.overlay SK scene is equal to your overlay. But we're not going to create that right now. You can play around with that. That's if you want actual 2D stuff on the screen. We're going to create a gesture recognizer to handle the tap so that you can kind of do that zoom in stuff. So what we'll do is we will say var gesture recognizers is going to be equal to an NS mutable array. And we'll use the NS array because it did in the original Objective-C code, but we could use a regular array. We'll say gesture recognizers dot add object. So this is the Objective-C. We don't want add object. We want add objects from array, and the array we want to use is the scene view dot gesture recognizers. And what we'll do is we'll add a tap gesture recognizer, and you can also add a pan one and a double tap and all that stuff. But we'll just create a tap gesture for now. UI tap gesture recognizer. The target is going to be self. So where's this happening? It's happening on this controller. The action that we want it to perform is going to be a method that we call. So in order to do that, we have to use the selector, and we'll say handle tap. Now in order to do that, we just have to write a little function called handle tap, and this will make more sense now. We need to close this. So we can say function handle tap. So this is the function it's going to call when you tap. You can basically take the camera node that we created and move it. And this will be that SCN transaction. So we'll create an SCN transaction dot begin. And what's going to happen is we're going to change a bunch of properties within this SCN transaction, and it's going to animate them, everything that we do within the SCN transaction. So we'll create an SCN transaction dot set animation duration. So how long do you want this animation to take? We'll want it to take 1 second. Just in case you wanted to know when it's done, you could say SCN transaction dot set completion block. And because this is a closure and it's the last one, you can do a trailing closure. And we could just do a print line here, and you can do whatever you want once it's done doing this. You could say done. And then we'll take the camera node that we created, we'll set the position, and notice how we're just setting the position. We're not animating it. It will animate it on its own. We're setting it back -100. And then in order to make this happen, we say that we're done with our SCN, so we'll say SCN transaction dot commit. It's almost like a database sort of thingy, but that is going to do our animation when you click on the screen. So you could then go ahead and add a pan recognizer and a double tap recognizer and all that stuff, but we'll just do the single tap recognizer for right now. If you wanted to do a double tap, you do the same thing as the regular tap, but all you do is you say tap gesture dot number of taps required equals 2. So that way, you could do a double tap, you could do a triple tap. Maybe a box takes a couple of hits in order to open up, so you can say number of taps required in order to work. So then we can add it to our list of gesture recognizers. Add object, and we'll just add the tap gesture, just so we have a list of gestures. And then we just have to register the gestures with the scene view. So we can say scene view dot gesture recognizers is equal to gesture our list of gesture recognizers that we created. And at this point, you've basically set up the scene. You basically set up the initial world. Now we want to set up the scene. So we want to set up our lights and our elements and our environment. So what we're going to do is we're going to say that the scene, which we created up above, we're going to initialize this thing. So we're going to say that the scene is equal to a new SCN scene. And what we need to do is we need to set up our environment, and we need to set up our scene elements, and we need to also set up our initial lighting, just so we can see something. So we'll just create a function called setup in, we'll just copy this, and we'll create one called setup scene elements, and we'll create one called setup initial lighting. So no errors there. So let's work on setting up our environment. So what setting up the environment basically involves is setting up the camera angle, setting up the camera orientation, and then adding some initial lighting to the scene. We will create some geometry for the floor and the walls. So what we're going to do is we're going to create the main camera. And we're going to do camera node is equal to a new SCN node. So like I said, everything is an SCN node. We're going to set the position of this camera. And you're wondering how we're going to turn it into a camera. You'll see in a second. So the position is going to be equal to a new SCN vector 3 make. So we're going to make a new SCN vector 3. What's our X, Y, and Z? We're going to do 0 on the X, 0 on the Y, and 120 on the Z. And then we'll create a node that will manipulate the camera orientation. So we'll create a node to manipulate the camera. We got to create a camera handle. So we'll just go up here, copy this, and we'll say camera handle is a new SCN node. And we'll say down here that camera handle is equal to a new SCN node. We'll say camera handle dot position is going to also be equal to a new SCN vector 3 make. So it's just a position using 3 axes instead of just X and Y. We're using X, Y, and Z. We'll say 0, 60, and 0. And then we'll set the camera orientation, which will be another SCN node, camera orientation. So we can say camera orientation is equal to a new SCN node. And what we'll do is we'll take the scene and we'll take the root node. This is the root node of all the nodes. And we will add a child node to it. So this is similar to adding child in SKView, except you say add child node. And that has to be an SCN node. So we'll add the camera handle. And then on the camera handle, we'll add a child node, and that will be the camera orientation. And this way we'll be able to, you know how you have a hierarchy of nodes, so we'll be able to change the camera handle, which will in turn change the orientation and change just the camera node itself. So we'll have a lot of control over everything. So we'll add child node, and we'll do add the camera node. So we're kind of adding a node within a node within a node. And then we can just say camera node dot camera is going to be equal to a new SCN camera. So now we have a new camera. And then we're going to say that the camera node dot camera dot z far, and this is the depth limit, is going to be equal to 800. Now what you'll see is that if we turn the lights on, you'll see that the camera it's not able to see that wallpaper on the very end of the wall when it's all the way back. If you wanted to do that, you could change this ZFAR number and you'd be able to see that that wallpaper on the very end. It's just not going to render it because we're setting the max depth limit. And we want to see if the user's using a phone, and we want to set a couple of properties based on that. So we'll say if UI device dot current device dot user interface idiom is equal to UI user interface idiom dot phone. If it's a phone, then we'll say camera node dot camera dot y FOV, the field of view in degrees, is equal to 55. And if it's not a phone, maybe it's an iPad, then we will set the X field of view. So then we have to say camera handle transforms, and what we want to do is we want to create a list of or an array of SCN matrices, all the transformations that the camera is going to do. We're not going to use a bunch of transformations, we're only going to use one, but in case you wanted to do something really cool with this, you can. So this is going to be an array of SCN matrices 4. So we'll say camera handle transforms is equal to an array of SCN matrix 4, and this is that new array syntax. And we're going to create 10 of these. And the repeated value is going to be a new SCN matrix 4. And then all we have to do is set the float on each one of these. I haven't found a faster way to do this yet. Maybe you know a faster way. So then we can say down here, we can say camera handle transforms dot insert. And what we want to do is we want to insert the current camera transform. This is a matrix. So we want to say camera node dot transform. It's about the position and the direction, and we want to put this at index 0. What we're going to do is we're going to create a position here out of an SCN vector 3 make. Place this at 200, 0, and 1000. And what we're going to do is we're going to take the camera node's position, the current position that it was at, and we're going to set it to be that position, but we're going to add 150 for the Z index so that it's even a little bit farther out. So we'll say SCN vector 3 make 200, and we're going to do position dot Z plus 150. We'll set the Euler angles by saying camera node dot Euler angles. This is going to be the roll, the yaw, and the pitch angle. So if you want to make the camera kind of look down at something. Now there's an easier way to make it look directly at something. You can just basically say look at this, but we're doing this all manually. So we're going to say SCN vector 3 make, and we're going to use pi, use a C float, and we're going to do negative m pi 2 for y. Well, we'll multiply this times 0.06. For y, we're going to do 0, and for z, we're going to do 0. So we want to just move the camera node on the pitch, the yaw, all that stuff. And then what we're going to do is we're going to add an ambient light. We are going to say ambient light node, which we haven't created yet. So let's just create a light, an ambient light. So we can say var ambient light node is going to be equal to, you're like, how do you make a light? Well, you just make an SCN node. I told you everything is an SCN node. Okay, so we're going to do that ambient light node is equal to a new SCN node. And then what we're going to do is we're going to create a light on that. We'll say the light on that is equal to a new SCN light. And you're saying, well, how do you make it an ambient light? So what you'll say is ambient light node dot light dot type is equal to SCN light type ambient. So that's how you make it an ambient node. And then we'll set the color of it to be an ambient light node dot light dot color is going to be equal to a new SK color from the SpriteKit. And we'll say that the white is going to be equal to 0.3 and the alpha is going to be equal to 1, meaning it's not going to be transparent at all. We just need to add that light to the scene. So we'll see scene.rootNode.addChildNode, and we'll add the ambient light node. So we added an ambient light to the scene. What we're going to do is we're going to add a key light, like a spotlight. So we're going to add a spotlight to the scene. Create a spotlight node, and we'll create a spotlight parent node. So we'll just say var spotlight node. It's going to be an SCN node. And we'll say var spotlight parent node with which to place the spotlight in. So now we can say spotlight parent node is going to be equal to a new SCN node, and the spotlight parent node dot position. Hold on, I must have made a boo-boo up here. There we go. So now we can say position. We're going to set the position of the spotlight node, and we're going to set it equal to SCN vector 3 make, and we're going to say 0, 90. So that's our spotlight parent node, and then we want to create the spotlight itself. So we say spotlight node is equal to a new SCN node, and then what we're going to do is we're going to say that the spotlight node dot rotation is going to be equal to an SCN vector 4 make, and this time you have X, Y, Z, and W. Y, Z, and W is going to be equal to a C float, and that C float is going to be negative pi 4. And you can see if you hold command and you click on that, you can see that pi underscore 4 is pi divided by 4, pi underscore 2 is pi divided by 2, etc., etc., etc. Now we want to configure that node to be an actual spotlight. So we can say spotlight node dot light is equal to a new SCN light. We can say spotlight node dot light dot type is equal to SCN light type spot. We can say spotlight node dot light dot color is equal to SK color white 1.0 alpha 1.0, and we're going to say that it does cast shadows. So spotlight node dot light dot casts shadows is going to be equal to true. So like our ball, we want our ball to have a shadow cast over it, and then we want to say spotlight node dot light dot shadow color, so we can tell the color of the shadow itself is an SK color, and the white is equal to 0, and the alpha is equal to 0.5. So it's like a gray. It's a half transparent black, I guess. Spotlight node dot light dot z near, the minimum distance between the light and visible surface for casting shadows, is equal to 30. Spotlight node dot light dot z far, the camera's depth limit is equal to 800. The light's shadow radius is going to be equal to 1.0. The light's spot inner angle, the angle in degrees of the area fully lit by the spotlight, is equal to 15. And the spot outer angle is equal to 70. And then we're just going to use our camera node, and on the camera node we're going to say add child node, and that's going to be the spotlight parent node. And in the spotlight parent node we're going to add the spotlight node. Okay, yeehaw. So now we're just going to add the floor, and for the floor we're going to create a floor. It's going to be equal to a new SCN floor. It makes this infinite plane. We're going to use a new SCN floor, and the floor dot reflection fall off end is going to be equal to 0, and the floor dot reflectivity is going to be equal to 0, so we don't want a reflective floor. And then we're going to say floor node, which we haven't created yet. We're going to go up here, we're going to create a var floor node is equal to a new SCN node. We're going to go back to our floor node, and we'll say floor node is equal to a new SCN node. Then we just got to change a bunch of geometry and add the wood to the floor. So we say floor node.geometry, we're going to do this a lot, so I'll copy that, is equal to floor. So we're going to create this infinite floor that is the wooden floor, just because it's going to go on forever. And then we're going to say floor node.geometry.first material. So we're going to add the material to this floor. Remember, the diffuse is the color. For the contents of that, we're going to set wood.png. So in order to do that, what we're going to do is we're going to create some folders. So what you want to do is you want to create a new group, which is like creating a new folder. And you're going to call this resources. And this is the way that you structure where you're going to put your assets in a SceneKit app. And then in that one, you're going to also create a new group called images, but that image is going to be with a lowercase I. And then in there, we're going to drag our wood for our floor. Make sure you create a copy. Now we have the wood on the floor. So we can say floor node.geometry.firstMaterial.locks ambient with diffuse. We want to make sure that it responds equally to ambient and diffuse lighting. If this all doesn't make 100% sense, it's really okay. First material, we're going to set the diffuse.wrap S, and we're going to say that's equal to an SCN wrap mode.repeat. So we're going to make sure that the wood repeats on basically the X and Y, even though it's not X and Y, it's S and T. It's going to be SCN wrap mode.repeat. If you've ever done CSS and you've set a background and you just say that it repeats on the X and Y, this is kind of what that's going to do. It's going to make that wood pattern repeat. And then we need to set what's called a MIP filter. We're going to say SCN filter mode.linear. And what we're going to do is we're going to set a physics body for the floor so that the ball can bounce off of the floor. So remember, you set your physics body equal to a new SCN physics body, and you're going to set the type be equal to an SCN physics body type dot static. So the floor is going to be static and the shape is going to be nil. And what we're going to do is we're going to set restitution, and I believe that's a little bit of bounce. So we're going to say floor node dot physics body dot restitution is going to be equal to 1.0. You're going to do scene.root node.add child node, and we're going to add the floor node. So basically, you're going to add the floor to the scene. So that's that. So if we run this, let's see if we get any errors. We don't have any errors. So look at that. And you can click, and we get our movement. So this is pretty awesome. You could even detect where the mouse is on the screen or where the finger is tapping and make them move in that direction. But right now we're just making them move forward. So this is that SCN transaction. What we did was we set the Z position and we said animate it over 1 second. And it's like, fine, I'll animate it. SCN transaction, no problem. Commit it. And we're going somewhere, but we're not, because this floor, remember, it's an SCN floor. An SCN floor is basically an infinite floor. Let's set up the scene elements first. We're going to create the walls now. So we'll say let wall geometry be equal to a new SCN plane. And the width is going to be 800 and the height is going to be 200. We want to say wall geometry dot first material dot diffuse. Remember, diffuse is the color. And we're going to set the contents be equal to that wallpaper that Apple gave us, .png. So we need to bring in that wallpaper. So here's the wallpaper. So we will drag that into our images. Copy. All right. So then what we want to do is we want to set a contents transform on that. I know there's a lot of stuff that you couldn't possibly know, but that's okay. Transformation applied to the materials properties visual contents. That's going to be equal to a new SCN matrix 4 molt. And for this, we're going to create a new SCN matrix for make scale. And we're going to do 8.0. We got a little bug here, 2.0 and 1.0. For this mat B, matrix B, we're going to do SCN matrix for make rotation. And we're going to use, for the angle, we're going to do C float because math pi is a C float. And we're going to do pi divided by 4. X, we're going to do 0.0. Y, we're going to do 0.0. And Z, we're going to do 1.0. For the first material, we're going to set a wrap S and wrap T, which is like our repeat pattern for X and Y, but it's S and T. So we're going to do diffuse.wrap S, and that's going to be equal to SCN wrap mode dot repeat. We're going to do the same thing for wrap T. So SCN wrap mode dot repeat. And we're going to set the first material not to be double-sided because we don't need to render both sides of the wall, which will make the app faster. We only need to render the one side with the texture. And we'll say wall geometry first material dot locks ambient with diffuse. Whether the material responds identically to both ambient and diffuse lighting. We do want it to respond to both ambient and diffuse lighting in the same way. That's our back wall, but that's just the geometry of the wall. So what we have to do is we have to create our back wall node. So we'll say wall with baseboard node. It's going to be equal to a new SCN node because it's that wall with the baseboard. The geometry is going to be equal to wall geometry. And we're going to say wall with baseboard dot position is going to be equal to SCN vector 3 make. So we want to set the position of this to be 200, 100, and -20 on the z-axis, so a little bit farther. We're going to set the physics body on that wall with baseboard so that if the ball does eventually hit it, it will bounce off of it. So we'll say physics body is equal to a new SCN physics body, and the type is going to be an SCN physics body type dot static, so it's not going to be able to be moved, and the shape is going to be nil. So then what we're going to do is we're going to say wall with baseboard dot physics body dot restitution is going to be equal to the same restitution as the floor so that they react in the same way. And then we're going to say wall with baseboard node dot cast shadow is going to be equal to false. So we don't want it to cast a shadow. What we're going to do is we're going to create just a node for the baseboard because you can see that we have the wallpaper, but that doesn't have the baseboard on it. We need to create something just for this baseboard on the bottom. So we'll say let baseboard node be equal to SCN node, and the geometry is going to be an SCN plane, and the width of that is going to be 800. The height is going to be 8, so it's that small baseboard on the bottom. So now we're going to say baseboard node dot geometry is going to be dot first material dot diffuse. So this is the content of it is going to be equal to that baseboard dot JPEG. So you notice we're using PNGs and JPEGs. We just need to grab that baseboard and import it in here. Finish. And we just want to say that it's going to repeat on the X, but not the Y, up and down and left and right. We only want it to repeat on the kind of the X, which is the wrap S. It's going to be equal to SCN wrap mode dot repeat. And then we're going to do the same thing again. We're going to do baseboard node geometry first material double-sided equals false, so we don't want it to appear on both sides. And then we'll do the same thing but with lock ambient with diffuse to true, so we want to make sure that the ambient and the diffuse are using the same properties. Baseboard node position we'll set to an SCN vector 3 make, and on the X that'll be 0. Y we will set to negative wall with baseboard node dot position dot Y, and the Z we're going to set the position well, let's set the position of the y plus 4, and the z will do to 0.5. For the baseboard node cast shadows, we do not want it to cast shadows. Now we're going to deal with the wall with baseboard node, and we're going to add the baseboard node to the wall with baseboard node so that one node will sit inside of the other. And then we have to add the whole thing to the scene. So we'll do scene.rootNode.add child node, and we'll add the wall with baseboard node to that. So now we have everything added, and we've made the geometry. So we should be able to run this. Let's see what happens. So we have our floor, which looks really nice, and you can't really see the end of the wall, but if you do keep clicking, eventually you get to that wall. And there's the wall, and looks like the spotlight hits it really nice. So that's pretty cool. And it works in landscape. And we see our baseboard. So we can actually set the Z far to be a little bit higher. And that will allow us to see the wall clearly on the first time because it's going to render it right away. Yeah, now you can see the wall right away. But you can expect that that would mean that it has to render more in order to do that, which is not necessarily a bad thing. Depends on your application. We'll just call this setup initial instead of setup initial lighting because we're going to also use that function to add the ball and all of its physics properties. So if you can click that with the command click. So now we'll set up that initial dark lighting. So that initial dark lighting, and we'll say ambient light node. We'll reuse the ambient light node that we had from before, which is good for memory. We'll say that the color of that now is going to be an skcolor.black color. So we're creating a black ambient light. And we're going to say that the spotlight, now we're reusing this as well, .light.color is going to be equal to an skcolor.black color as well. And the spotlight position is going to be equal to an SCN vector 3 make, and we're going to set that to 50, 90, negative 50. And because the spotlight has to be up above, and the angle of it, the Euler angle, the Euler angles is going to be a vector 3 make, and we're going to use negative pi divided by 2 for the x times 0.75. So what you have to do is you use a C float, and you're going to do negative m pi 2, which is math. It's pi divided by 2. I want to say math.pi because I'm so used to JavaScript and other languages that use math.pi. So then you're going to do C float, and we're going to do math. We're going to do pi divided by 4. So m pi divided by 4. So m pi underscore 4. We're going to multiply this times 0.5, and the z is just going to be 0. So now we're going to have these spotlights, and we're going to put the rolling ball on next, and we're just going to like put it in a position and then just kind of let physics do its thing. So what we're going to do is we're going to say rolling ball, which we didn't create yet. So we can create it up here just in case you want to reference it later and do all sorts of fun stuff. So you'll say var rolling ball is going to be an SCN node. And so now we'll say rolling ball is equal to a new SCN node, and we can set the geometry at the same time as an SCN sphere. So this is the ball as a sphere, and we'll do the radius as a ball radius. Okay, and so what we have to do is we have to just set that constant. Up here we'll do ball radius, and sometimes when you want to do constants, it's helpful to do them in all caps. That's kind of the status quo sometimes, and especially when you're looking at Objective-C code, you'll see stuff like that. Oh, a CG float. So we just have to set that ball radius to be a CG float. Okay, now we should be good. So what we want to do is we want to add the basketball image to the ball. So we'll say rolling ball dot geometry dot first material. We'll copy that because we're going to add a couple of things. Dot diffuse, which remember is the color, and we're setting an actual image as the color. So we're going to set a UI image, and we're going to use UI image named, and the name we're going to use is ball dimpled. We just got to grab ball dimpled and add it in here. Should have ball dimpled.png. There we go. And notice this time we used UI image named, where up here we just set it as a string. So you can do it either way, just to show you a couple of different options. And we'll set the first material dot emission contents is going to be equal to that UI image named ball dimpled. We're going to set the emission intensity equal to 0, which I believe will turn it off. So maybe this isn't even necessary. I'm not quite sure. So we'll say rolling ball dot physics body. So now we'll create the physics part of it. SCN physics body. So we're going to create a new SCN physics body. And the type of the body, this one's going to be dynamic. So you could say SCN physics body type dot dynamic. And the shape is going to be nil. We're going to set the restitution. So we're going to say rolling ball dot physics body dot restitution. The bounciness of the ball is going to be 0.9, so it's got a good amount of bounce. And then we can say rolling ball dot physics body dot angular velocity. So you're just going to give it a little bit of spin on its initial drop down. So we'll say SCN vector 4, and we could do an SCN vector 4 maker, just an SCN vector 4. And we'll do X is 1, Y is 1, Z is 1, and W is 1. So it's just going to have the tiniest spin. Obviously, you could do more, and when it drops, it would just go flying. It'll probably hit those walls that you could make. So we'll set the rolling ball position equal to the position of the camera initially, which before was SCN vector 3 make. Which was 200, 0, and 1000. We won't add 150 to it because adding 150 moved the camera back a little bit. We want the camera to be able to see the ball. So then what we can say is rolling ball dot position is equal to position. And what we can say is rolling ball dot position dot y. So we're going to just put the ball up in the air is going to be equal to a C float. We're going to say the ball radius times 8. So it's going to be 4 times its height or width in the air. And then what we can do is we can add to the scene the ball. So we can say scene.rootNode.add child node, and we can add in the rolling ball. And what we can do is we can have the camera kind of look at that ball. So now all we have to do to finish this up is just create an SCN transaction and fade in the screen, which will give it a nice little fade in. So we'll do SCN transaction dot begin the animation duration. So we'll do SCN dot set animation duration for 1 second. The completion block to do something after it's finished. So all we're really doing here is we're using the SCN transaction as a timer, essentially. So we're going to do SCN transaction dot set completion block, and because this is one closure here, we can use that as a trailing closure. We're going to set the spotlight node color to just a white 0.001 and the alpha as 1, and we're going to call SCN transaction dot commit. Within the completion block, we're going to say SCN transaction dot begin. The animation duration of this one to be 2.5 seconds. Then we're going to turn the lights on completely by saying spotlight node light color is equal to white 1 and alpha 1. Notice we have to do self because we're within the context of a closure. And after all this is done, we have to just do SCN transaction dot commit. which will make the whole thing happen. So now we don't have any errors. We can run this. Fades in after 1 second, and this will run much faster on an actual device. Ball starts bouncing. We can turn this on its side here, because we threw the ball up in the air. Now you can see the ball is even rolling a little bit. So I'll do this one more time just for fun. Fades in. So you get a nice fade in there. We get this nice stage. And even while that's going, we can kind of zoom in on it. We can keep going. And eventually we should get to our wall. So that's just a quick introduction on SpriteKit. I'll see you next time.